Bismillahirrahmanirrahim. Assalamu alaikum, students. Today I am going to start a course for physics, a course in physics for class 12 students of our state, Jammu and Kashmir, and in particular for our state and in general for our country, because the syllabus is throughout the same. So I name this course. Let me name the course. So the course name is Physics for class 12. As I told you in the beginning, in this course, I will cover and uncover all the syllabus prescribed by J.K. Bose and Central Board of School Education (CBSE) for all higher secondary level schools, I mean for class 12 students in physics. So let me give you the brief outline of the syllabus. The syllabus for physics in class 12 is divided into 10 units. The structure of the units is like this. Unit first is electrostatics. Then we have unit second, which is named current electricity. Then we have unit third, it's magnetic effects of current. And magnetism. We have unit 4, electromagnetic induction and alternating current circuits. Then we have unit 5. Unit 5 is electromagnetic waves. Let me change the color. It is electromagnetic waves. Then we have unit 6, is optics. Then we have unit 7, dual nature of matter and radiation. Then we have unit 7. Then we have unit 8. Unit 8 is atoms and nuclei. Then we have unit none, semiconductor, electronics, then we have unit 10, communication systems, systems. This is the broad outline of the syllabus in terms of the unit structure. And you have two recommended books. If you see your books published by NCERT, they come in two parts, part first and part second. And the first 5 units, that means up to this fifth unit, part 1 of NCERT contains first 5 units, and the rest of the 5 units starting from optics to communication systems are contained in part 2 of NCERT textbook. So let me give you the brief outline of the ideas which we have to discuss. Then we will go into the details. Firstly, let me talk of the first unit. In electrostatics, if you see what is electrostatics, it is that branch of physics which deals with the study of charged particles at rest. Now, when charged particles are at rest, are they are moving with low speeds so that their motion can be ignored. They exhibit certain phenomena. We have to discuss in this unit all those situations, most of the situations pertaining to the charged particles at rest. That's why we call it electrostatics. You will see in this unit the ideas like Coulomb's law. You write Coulomb's law as F is Q1 Q2 by R square, which is the force law in electrostatics. You will discuss idea like superposition principle. What is superposition principle? We will come to know. You have to express this Coulomb's law in vector form. You will see statements like charges repel and unlike charges attract. Then you will see an idea called Gauss's law, which is written in integral form this way. You will see this type of equation, closed integral E dot d is q by epsilon naught. Then in this unit, first you will see applications of Gauss's law. We will discuss how Gauss's law is stated mathematically. It is stated in this through this equation. When you write it in integral form, then we have to see the applications of Gauss's law. Using Gauss's law, we have to uh, find electric field due to certain charge distributions. Then in this electrostatics, we will talk of ideas like, let me use this color, electric potential energy. You see expression like this, your R is A Q1 Q2 by R. Then we will talk of another thing which is called electric potential, or some other color. So we will talk of electro electric potential. We have to talk of the electric potential. We'll talk of capacitors, different type of capacitors. We'll talk of capacitance. Capacitors have capacitance. Then at the last, we will discuss an accelerator called Van de Graaff accelerator. There's a brief outline of this unit. Then in unit second, let me use next page. In unit second, that is current electricity. Which ideas we have to discuss? First, we define electric current. You see equation like this: I is dq by dt. Then we talk of current density. Current density, it is denoted by J. You will see a relation of this type. I is equal to ENA VD. This relation you will establish I is equal to ENA VD. This VD has a name, it is called drift velocity. Then we have to talk of Kirchhoff's rules. Kirchhoff's rules. There are rules. Kirchhoff's rules are used to analyze circuits. For example, if there is this circuit, if I have this cell connected to two resistors, let be this resistor be R1, this resistor be R2, and let this battery be supplying 2 volt. Now current will flow in this main circuit and it will split. Some of current will go through I1, some of current will go through R1, and some of current will go through R2. Now if R1, R2, values of R1, R2 are known, battery voltage is known, which is 2 volt. Now if you are asked to find how much current will flow through battery, how much current will flow through R1, how much current will flow through R2, this means analysis. That means some parameters in the circuit are given and other parameters you have to predict. That is analysis. And in analyzing these circuits, in this current electricity, we have to consider only DC circuits, direct current circuits. So we'll state Kirchhoff's rules. One is Kirchhoff's junction rule, then is Kirchhoff's loop rule. Then we will make use of those rules to find the circuit parameters of various circuits, and some other parameters are given. Then there are another ideas in current electricity which we have to discuss some of the devices. For example, there's a circuit called Wheatstone bridge. We have to discuss that Wheatstone bridge is used to determine an unknown resistance from some known resistances. We have to discuss that. Then we have to discuss the modified form of Wheatstone bridge, which is called a meter bridge. You have to do an experiment using this meter bridge as well in your lab course. So we will discuss meter bridge. Then we will discuss in this current electricity another thing which is called the potentiometer. Potentiometer is also a device which is used to compare the EMFs of two given cells. For example, it can be used to find the internal resistance of a given cell. That is also your one of the experiments in your lab course. So this was the brief outline of this current electricity unit. Then there is third unit, magnetic effects of current and magnetism. You know, if let me use some other color here. If I have some current carrying wire, this current carrying wire is a magnet. It has a magnetic effect. It is a magnet. Now we have to discuss these magnetic effects in this particular unit, and there are two chapters in an NCRT pertaining to this unit. Third, you will see the ideas like Biot-Savart law, then its applications using these Biot-Savart law. You will find the magnetic field due to certain current distributions. We will see the definition of ampere. We will talk of parallel currents and anti-parallel currents, and we will talk of Earth's magnetic field in the magnetism portion. We will talk of physical quantities like magnetic moments, right? We will see the behavior of a given magnetic dipole inside the magnetic field. We will talk of Gauss's law for magnetism. You see, in magnetism, we say monopoles means isolated north or isolated south pole cannot exist. Now, this monopoles cannot exist. This statement is mathematically written in the form of Gauss's law for magnetism. So, this is a brief outline of this unit. Third, let me move. In unit 4, we have to discuss electromagnetic induction. What is electromagnetic induction? A simple idea I will give you. If I have a copper wire in this fashion and in its neighborhood, if I take some bar magnet, for example, and I move this bar magnet relative to the loop of wire, what will happen with certain velocity? You can move magnet towards it or away from it, or you can do the reverse. You can move the loop with respect to the magnet, or you can move both. There should be relative motion between the loop and the magnet. When this happens, current will flow through this current, thus through this conductor. Now, what is the direction of that current? How much current will flow? That all comes in electromagnetic induction. There is a law which we have to discuss, which is called Faraday's law of induction. And there is another thing, another law, which is called a Lenz's law. We have to discuss those ideas. There are also two chapters in NCRT textbook pertaining to Unit 4. We have to discuss one is electromagnetic induction. Second chapter discusses alternating current circuits. Now, alternating current is such kind of current. The current changes with time. First, in first half of its cycle, it is one has one direction, then it reverses direction. It changes sinusoidally with time. Such a current is called alternating current. Now, how such current is produced and what are its properties, how we define power in AC circuits, we have to discuss all those things. We have to discuss a circuit which is called a series LCR circuit, where we have inductor with inductance L. We have to talk of inductance. Then we have a resistor with resistance R, and I have a capacitor with capacitance C. Then I connect it with some AC generator. This is called a series LCR circuit. We have to do the analysis of this series LCR circuit, its various properties we have to discuss in this unit. We have to understand the idea of transformer in our homes, in our transmission systems. We have an essential, important device which we use, which is transformer. How this transformer works, we will discuss step up transformer, step down transformer. So this is the broad outline of this unit 4. In electromagnetic waves, we will see that firstly we have to discuss an idea called displacement current. We have to discuss Maxwell's equation, and we will see how Maxwell modified the idea. First, there were four laws. He make a change in one of the laws. Now, those equations are called Maxwell's equations. He introduced the idea of displacement current. We have to discuss what is a displacement current, how it is obtained, and what are the implications of introducing displacement current. Then we have to discuss electromagnetic spectrum. You see, light is an electromagnetic wave, but there are other electromagnetic waves like we have UV rays, we have gamma rays, we have X rays. We have to discuss all the electromagnetic spectrum. We see all of these electromagnetic waves, whether they are UV rays, X rays, gamma rays, or visible light, they move through vacuum at speed c equal to 1 by square root of mu naught epsilon naught. We'll discuss this relation. We will discuss the electromagnetic nature of light. Right? This is the broad outline of Unit 5. Let me move. Where is my Unit 6? Yes, the next page. Where is Unit 6? This was Unit 5. Where is next page? There, I have some pages. Now in Unit 6, we have the optics. You know, optics is the study of propagation of light through various materials and its properties and propagation. Now, this study optics is divided into two parts. One is called ray optics, second is called wave optics. In NCRT textbook, there are also two chapters pertaining to this unit. One discusses ray optics, second discusses wave optics. In ray optics, we discuss those situations where light encounters those obstacles or those uh, openings whose size compared to wavelength of light is large. If A is the size of the obstacle and lambda is the wavelength of the light, then in ray optic situation, lambda, let me write it neatly, lambda is much less than A. That means the obstacle size is large compared to wavelength of light. Remember, the wavelength of light is 400 nanometer to 700 nanometer. 1 nanometer is 10 raised power minus 9 meters. So when we say visible light, we refer to these electromagnetic waves which lie in this wavelength zone, right? So ray optics, in ray optic situation, there is no diffraction. Diffraction is almost negligible when lambda is much less than a. That means obstacle size is greater than the wavelength. So when light hits some glass slab, some prism, some mirror, some lens, this is the situation of ray optics. So we will be talking of laws of reflection, laws of refraction, all those situations we have to discuss in ray optics. Then in wave optics, we have to discuss those situations when light encounters or passes through those openings or barriers whose size is comparable to the wavelength of light. Now, in this situation, light diffracts, it bends, it doesn't travel straight. Oh, under this condition, we have to talk of interference, we have to talk of diffraction, and in interference, we have to discuss an important experiment in physics which is called Young's double slit experiment, right? So, this is the broad outline of this unit. Now, in unit 7, dual nature of matter and radiation. Right now, we know that matter and radiation both have dual character. That means matter, which in most circumstances behaves like a particle, under certain circumstances behaves like a wave. For example, you can diffract electron. We talk of electron diffraction, we talk of interference with regard to electron, like we talk of the interference and diffraction with regard to light. Similarly, radiation, which under certain most circumstances behaves like a wave, under certain circumstances it behaves like a particle. For example, in case of photoelectric effect, we have to discuss that photoelectric effect. In photoelectric effect, light behaves like a stream of particles which we call photons. We will discuss this important relation suggested by de Broglie, lambda is equal to h by p, where h is Planck's constant with value 6.6 into 10 raised power minus 34 joules second. Lambda is called the de Broglie wavelength and p is the linear momentum of the particle. This relationship connects the wave character, which is uh, embodied in this wavelength, with the particle character, which is represented in this equation by the linear momentum. Momentum is the particle characteristic, wavelength is the wave characteristic, but this equation connects this particle and this wave character of matter as well as radiation. So we have to discuss this. This is the broad thing outline of this unit. Let me move to unit 8. In unit 8, we have to discuss the properties of atoms. Remember, the atoms were when they were postulated that matter consists of atoms, they were thought at that time they are indivisible. Now we know atoms have internal structure, and you must be knowing the important experiment Rutherford's alpha particle scattering experiment. We have to discuss that. We know Rutherford's alpha particle scattering experiment establishes that inside atom there is a tiny center portion called nuclei and there are electrons surrounding that. Right? Most of the matter is empty because most of the space in the atom is empty. We have to discuss this experiment and other related properties of atoms. We have to talk of the Bohr's model of atom. We have to discuss there are also two chapters pertaining to this unit in NCRT. One chapter discusses atoms, second discusses nuclei. In nuclei, we have to discuss some properties of nuclei. We have to discuss, for example, the binding energy curve we have to discuss. This is the main thing in this unit. Now, in Unit 9, semiconductor electronics, we know semiconductors have transformed our electronic industry. There's an important element of semiconductor electrons which is called p-n junction diode. P-n junction diode is a non-ohmic device, two-terminal device. Its IV characteristics is like this. We have to understand this IV characteristic. It's like this. We have to discuss the forward bias characteristics, reverse bias characteristics of p-n junction diode. Then there is another element which is made out of these p-n junction diodes. You can consider that as two back-to-back diodes, which is transistor. We have to discuss transistor. We have to discuss its IV characteristics. It comes in two varieties, NPN and PNP. What that means, we have to discuss that, their construction and working. We have to discuss transistor can be used as a switch, it can be used as an amplifier. Those applications we have to discuss in this year, right? Uh, what else comes in it? Yes, we have to discuss the special purpose PN junction diodes. There are some diodes which are called special purpose PN junction diodes. They are modified versions of the routine PN junction diode. We have discussed them. For example, one is Zener diode, which can be used as a voltage regulator. There is another thing which is called light emitting diode. We have to discuss that. There is another thing called photodiode. We have to discuss that. Then there is another important portion of this unit is the logic gates. When we discuss logic gates, what are logic gates? There are and, nor, and. You will see terms like this: OR gate, NOR gate, XOR gate. Those we have to discuss, and their behavior is expressed using the truth table. We have to discuss how to express the behavior of a logic gate by means of a truth table. Then we unit 10, communication systems. Now in this communication systems unit, we have to first understand the components of a given communication system, components of a given routine communication system, components of a communication system. You will come to know terms like transducer, range, amplification, uh, then amplification, modulation. There is an important idea in this unit which is called amplitude modulation. Idea of a carrier wave, why it is required. These are the main concepts which we have to cover up. Now, in the next lecture, this was just the brief outline of your syllabus. In the next lecture, we will take up this first unit, electrostatics, and go into its details. So, join me and complete your syllabus. Don't waste your time and don't forget to like, share, and subscribe my channel. So I stop here. Thank you. God bless you. Assalamu alaikum.